Good day, everyone. This is Orekoya from Yomishegun, Physics Mathematics Fundamental on YouTube. Please, before we go into today's topic, do not forget to like, share, subscribe, click on notification button to have more of my video. Today, we are taking a topic under differential equation. Now, this is an idea of differential equation. Differential equation, I will shorten it. It's an equation that have a derivative, the y dx, which can be written as y prime. So this differential equation is in two parts. We have what is called ordinary differential equation. Then we have what is called partial differential equation. For ordinary differential equation, we have the form that involve a dependent variable with respect to independent variable. But for the partial differential equation, it has more of independent variable. Like we can have this particular y is a change in y with respect to independent variable x together with the same dependent variable y with respect to another independent variable, let's say t. So these are the two aspects of differential equation. We have the ordinary differential equation, then we have what is called partial differential equation. For partial differential equation, it has dependent variable y with respect to two or more independent variables such as x and t. But for the ordinary differential equation, it has a different variable y with respect to just only one variable x. So in my subsequent work, I'm going to outline example of ordinary differential equation and partial differential equation, because this is not what we are to do today. Today we want to do application of different ordinary differential equation in solving a problem. Now, before we can solve the particular problem, it is assumed that you have gone through calculus course that cover differentiation and integration. So look at this particular question exercise. The question says, if the population of a country doubles in 50 years, how long will it take for the population to triple under the assumption that the rate of growth is proportional to the initial population of the country? So what this one is saying is, if we have the number of population of the country to be n, and the time of change is t. According to this question now, it says that in 50 years, when t is 50, so t is in years, the population double. This particular population, this is number of population. So in this particular 50 years now, the number of population doubles means we are going to have 2n. The question now says, what time will the population triple? So it's saying that what time t will the population triple, given an initial condition that the rate of growth of this population, the rate r of growth of this population, which is change in population, international change in population with respect to instantaneous change in time, that is the rate, is proportional to the initial number of population. Now, in order to solve this problem, we can remove this sign of proportionality by putting constant k. So this particular rate, which is the n dt, can now be written with kn. So this proportionality constant has removed this proportionality symbol. Now, like what we have here now, we are having a dependent variable with respect to independent variable. Dependent variable here is n. Independent variable here is t. So what we are going to do now is we want to use a method called separable variables. So in this case now, the variable that we are having here are variable n and variable t. So we want to separate them. Let all the n be on one side and t be on the other side. So here now, I can have my n coming here. So it's going to be the n divided by n. Then I'm going to have my dt coming here, so it's going to be kt. Now, at this junction, in order to, find an expression, the function of n, we are going to, this place is supposed to be dt. We are going to integrate both sides. So when we integrate this side, we are going to also integrate this side. Now, the initial condition is that the population starts for the first case now. The first case is talking about the population n start from n to 50 in the first case, so that the population will double. So what we are trying to say is this. I'm going to write this particular initial, let me first of all integrate before I put the limit of our integration. So if I want to integrate this side now, I'm going to have it as ln n. Integral of the n divided by n is ln n. So this place, and then the initial condition for the first situation is that our population changes from initial to this final, and the final is 2n. And when you integrate constant k remain as it is, and then the condition for the time is that the time starts from 0 in the first case to 50 years. Now, if I want to establish what I have here concerning these limits, I will have it as ln of 2n. Take away ln of this initial condition, n, is equal to, for this one now, when I'm integrating the t, it's going to be kt. So this k, we can take it outside the integration bracket, and I have t 0 to 50. And this can be written as k times, when you substitute 50 to t, we have 50, take away, when you substitute 0 to t, that is 0. So it's going to give us 50k. So according to law of indices, when we are subtracting, we are going to divide. So this expression we have here is going to be ln of 2n divided by this n. Then we equate it to 50k. 50k. Now, if we look at the scenario that we have here, this particular n, we cancel this n. So that ln 2 is equal to 50k. Now, if we divide both sides by 50, I'm going to have ln 2 divided by 50 is equal to the value for this constant k. Now, I want to evaluate this expression that I have here in my calculation. Ln 2 divided by 50 from the calculation is going to give us this particular value. I'm going to have ln 2 divided by 50 is going to give me divided by 50 is giving me 0.013 0.01386 approximately. So that's the constant k that we have for this particular standard expression. Now, that is the situation for when the population is double. Now, when the population is triple, what I have here now, integral the n divided by n is equal to constant k integral dt. If we evaluate this integral, the one we have here before is what I'm writing here. When you integrate dt, it's going to be k, then dt, in this particular is going to be t. Then the limit of our integration is always from 0 in this particular question to the time t that we are looking for. And then the limit for this one, integral of the n divided by n from standard integration is ln n. And the condition, according to what the question says, it says that the rate of growth is proportional to the initial population. So initial population is n up to the 3n, because it's triple as a time t. So now if we integrate this place now, we have this, and when we substitute this initial condition, it's going to be ln 3 3n, take away ln n. Then this is going to be k. When we substitute each of these limits, we have t minus 0. So this gives us a kt. And the ln 3n minus ln n actually means ln 3n divided by n, according to the law of logarithm. So this n cancels this n. So I have ln 3 left over as a kt. Since my k has been obtained to be 0.01386, so this expression can be written as a 0.01386 times t. So this is the t we are looking for. So to be able to get this t, we divide both sides by 0.01386. That's going to give, I'm bringing this one here so that we can easily see what our calculation is around this side. So I am still going to rewrite it. Ln 3 is equal to 0.01386t. So to get this t we are looking for, we divide both sides by this. So it's going to be ln 3 divided by 0.01386. And then from the calculation, ln 3 divided by 0.01386 is giving me approximately 79.3 years. So which can be rounded up to roughly 79 years. So the answer we got here is that in the time t, that means in the time 79 years, the population of the country will triple. I believe that you must have understood this particular type of question under ordinary differential equation. In my subsequent video, I'm going to put across some fundamentals that will also enhance your understanding of this type of problem in mathematics. Once again, please do not forget to like, share, subscribe, click on the notification button to have more of my video. Have a nice day. Bye.